right, hello, hello. If you are building agents, there are probably so many possible ways to build it. It could be multi-agent, they could be pipelined, it could be parallel, you could have an agent orchestrator, and there are different models you can select, different RAG pipelines. There are just so many variables every time you want to solve a problem, and there are so many problems to solve. So what we do is we let them cook. Essentially, we can take every single possible combination of configurations and we make them all fight, because that's what I love to do. I love competition. I love leaderboards. And you can just sit there, watch the leaderboard. You have 6 screens all looking, and you just see them all. They're all cooking. So first, I'll intro me. I'm Nicholas Pipitone. I'm the co-founder and CTO of ZeroEntropy. We build the search and retrieval models for RAG. So we train embedding models, we train rerankers, we do everything that we need to make sure that the agents have the best possible tokens in their token budget. Because that's what it all comes down to. The moment the agents start getting to 100, 200,000 tokens, they get confused, they don't know what they're doing. You essentially just have to compact them. And then every time you compact them, all they see are summaries, which is terrible. I mean, you can feel it. You know, you're talking to it, it only has the summary, you're trying to reference X, Y, Z, and it's like, I don't know what you're talking about. So, as always, we love competition, we love leaderboards. Every time we're trying to solve a problem, we want them to fight. So we even do this in retrieval. When you have a problem that you need to solve and you have a huge corpus of information, you have no idea which documents could be helpful. What you can do is you can have every single document fight every single other document. Like, hey, am I helpful? Am I helpful to this query? It's a simple pairwise comparison for the LLM. The LLM sees the query, it sees 2 documents. Which document is more helpful for the query? And you can distill this into very, very tiny LLMs so that on every single query, you can go ahead and scan thousands of documents, and then you get ELO scores on all of them. And that is essentially what we're able to offer in our models. And we love open source. We put all of our models on Hugging Face. You can download all of them, run them locally, and basically get the best possible tokens for your agent. Now, when we're actually deploying our models, we want to serve super fast inference. And that is a great question in and of itself. When you have hundreds of customers and they're dumping billions of tokens and you have a set of like a cluster of H100s, how do you optimize all of that inference? How do you make sure that the GPUs are being used fairly? You want to make sure people have good latency. You want to make sure one person can't capitalize the latency. There are so many possible algorithms. We should use ELO scores. We should make them fight. We deployed a huge system that allows a whole bunch of different Claude agents to basically take all of the logs of all of the inferences that need to be run. Every single inference is a matrix. Any single matrix takes this amount of milliseconds to run on the GPU. And you can combine requests, you can split requests, you can distribute them. You kind of want, when someone sends in 1,000 documents, and you have, let's say you have an 8 by H100, you want to sort the documents by length. Take the short documents in a big batch, send it to this GPU. Take the big documents in a small batch, send it to this GPU. Then all 8 GPUs finish exactly at the same time, and you return to the user in like less than 40 milliseconds. And fantastically, we get to take all of these metrics, the P50, P90, P99, and all of these agents are all competing for the best possible spot. And then they create a Python file, and it's fantastic. You just put that right in your repo, and bam, you have your P99 just dropped by like 70%. Here we show the results of being able to use it for what I'll call auto-optimize. Any type of optimization task, generalize it as far as you can. You have a function. The function has some input, some output. You want to connect the agents to a knowledge base so that they can figure out how to solve the function. They don't know the latest research. You have to give them the knowledge. And then you just let them run. Here this shows different collections of agents and agent orchestrators that are connected to different knowledge bases. Here what we're doing is we're trying to experiment with the different embedding models and see materially, like how much does the better embedding model improve the agent's ability to solve this other like separate optimization task. So we took 1,500 archive papers. All of them were huge, long, and complicated. You can't shove them in the context. It can only really take 1 or 2 archive papers. So the context is limited to like 0.1% of the corpus. And then essentially, we can check ZeroEntropy's embeddings, OpenAI embeddings, Cohere's embeddings, and we can let them run. I think you saw the results before. We'll click restart. This is a slow process, so it takes a while. But you saw what it looked like before, where essentially you see the iterations, you see each model, and then you see it slowly begin to optimize. Now, building this was super easy and so few lines of code. In order to make the optimization function, first you need a secret optimization function. And we put that away over here in secrets, and we make sure that it's on a separate machine, like the agents can't see the function that they're trying to optimize. And then you need to give all of the agents the tools that they need. They need to evaluate code. Very simple. You just give it access to execute Python in a sandbox, like this is less than 50 lines of code. You have search papers. It's an agent. You tell it, oh, you have this archive paper query. You need to convert it into keywords. You need to convert it into embedding search. You have to do the hybrid search, and we have this in less than 50 lines of code. Separately, we have all the indexing, building the chunks, OCRing it if there's not text available. And all of this here is built with Mastra and AI SDK from Vercel. Makes it super easy to both do the agent orchestration and also to quickly iterate over dozens of different models when you're trying to explore. And here we see the results. We let them cook. We have ZeroEntropy here at 16.8, and I believe this is measuring KL divergence between the target scores and the mystery function that it doesn't know. And then here we're seeing the other embedding models, and this is really coming down to the retrieved papers. So here we can look at the retrieved papers, and this lets you iterate. Because if you're seeing that a model hits this paper and then it immediately gets like a better score, then you know this paper was probably the one that caused it. You can even inject this paper into other agents now that you know that it's relevant for the thing that you're trying to optimize. And we can come here and we can share all of this code as well. If you want to chat. As I said, we love open source. And yeah, would love to hear if you have any questions.
What is your PDF parser recommendation here? It sounds like you're doing some OCR for the actual parsing paper into quality chunks. Like, what do you recommend? What are you guys using for that?
We've used a combination of different OCR methods. Often the top two we select is either DeepSeek's OCR, which can translate it into Markdown, or just like traditional OCR, like Google OCR, like that's often just much cheaper. So it kind of depends on the cost benefit. Like if you're gonna do like 1 million pages, and then you see that it might get expensive if it's like $10 per 1,000 pages or something. So yeah, it often comes down to that. Definitely, when you're doing this transformation, Markdown is the best. The embedding models of it, the rerankers, and then the downstream LLMs, like Markdown versus any other format like HTML or just unstructured text.
My understanding of this is that you're kind of like running a lot of brute forcing to find the right answer. Mm-hmm. Yeah. I'm assuming a lot of problems are like repeatable. They're the same problems that a lot of other people and agents are having. Is there any way to like extract things that work into higher level recommendations in like ZeroEntropy platform? Something that people don't need to rerun the same exact brute forces all the time.
Yeah, I mean, I guess the generalization of that knowledge base is something like Arxiv or even just on Hugging Face, people post like the different methods that they've used. So yeah, that's what I think connecting, like what we connected here was to archive papers. We keep it like super up to date. We make sure that we're able to pull anything that's potentially relevant so that we can embed them all and keep it all in the context. When we find new novel information, we have like, we personally internally have like a giga repo of markdown files that just gets massive, and they just fill it up with literally like 100,000 lines of markdown. Like it just goes crazy. And that just acts like a universal knowledge base. And then even then, we release our own archive papers. The way that we trained our reranker and our embedding models is fully on Arxiv. If you go to ZeLo, which is our ELO-inspired method, where like I said, for every query, we take the documents, we make them fight with small LLMs, and then we score them. And then that's the training signal for both rerankers and embedding models. And then we go through all of the details here so that it's actually pretty reproducible if you want to take our models off of Hugging Face and fine-tune them. In fact, you can take this entire archive paper, convert it to Markdown, throw it into an agent, and be like, fine-tune my model, use this algorithm.
Any other questions, please?
You guys use ELO-ranking for document?
Yep. We do, at train time, we do pairwise comparisons in order to be able to like take a query and then just score all of the documents. That gives us the training signal. But what we actually distill is like Q, D, score. So the reranker just sees a query in a document. It just needs to zero-shot the ELO. Like, it's not going to do a bunch of comparisons on the fly, because what we're really trying to do is make it very, very cheap. We've distilled this down to like a 0.6B model. We have it running at like almost like 1 million tokens per second on a single H100, so that we can just go through and scan like thousands of documents every time.
Is that repository public, or will it be made public?
Yes, I think it's not right now, but I'll make it public right after, and I can send you the link. If you do want to use our models, it's on ZeroEntropy.dev. You just, that's it. You just go to ZeroEntropy.dev, and you click the start button, and then you're right here. Where did I hear this? An event meetup. And then, yeah, you have your API key ready to go. And you can use embedding models. You can create collections of documents, stuff like that.
Thank you.